Hey everyone, this video is going to cover problems 1 and 2 from our 10.7, I think we were calling it part 2. So these problems are right here. The first one is 2 sine cubed is equal to sine squared. What we're going to do on this one is start by getting it equal to 0. Okay, so we have 2 sine cubed of x. Oops. I said we're going to get it to 0, so I'm going to subtract this sine squared over. And that equals 0 now. At this point, we're trying to think, how can we solve this algebraically? And you want to think factoring for this one. So if you look at the two terms, what do they have in common with each other? They both have signs in them, right? Smallest power of sine that we see is sine squared. That means we can factor that out. So we're going to go ahead and grab sine squared, put that on the outside, and if we factor it out, we're left with 2. We would have 1 sine left here, minus, remember when you factor out, you're dividing, so sine squared divided by sine squared is 1, and that equals 0. So then at this point, we're going to write these separately equal to 0. And solve. Okay, so we're going to take, on this one, the square root of both sides of the equation. Just gives us that sine would have to equal 0. Over here, we're going to add 1 and divide by 2. So we get sine has to equal 1/2. And at this point, you want to look on your unit circle. So you want to figure out where is sine equal to 0 and where is sine equal to 1/2 on that unit circle, all right? Sine is equal to 0 at 0, right? And at pi, and at 2 pi. Actually, at any multiple of pi. So we can write this as pi k, right? Where is sine 1/2? That happens at pi over 6. And 5 pi over 6. So we can put pi over 6 plus 2 pi k to represent all the coterminal angles. And 5 pi over 6 plus 2 pi k. Alright, so these are all of the answers. There's an infinite amount of answers, right? That represents all of them, if k could be any integer. Now we want to say, alright, what is the answer within 0 to 2 pi? Start listing these. If we start with our first answer here, x equals pi k, what do you get if you put in 0 for k? You get 0, right? So 0 is our first answer. If we put 1 in for k, we get pi. So pi is also an answer. If we put 2 in for k, we get 2 pi, but we don't want to include 2 pi in this list, okay? So we're done. And we move on to this. If we plug 0 in for k, we get pi over 6. If we put 1 in for k, we would be adding 2 pi onto pi over 6. That'd be too big, right? Because that would definitely be larger than 2 pi. So we're done with that one as well. And over here, same thing. If we plug 0 in for k, we get 5 pi over 6. If we plug 1 in for k, it's gonna be too big. So that is the final solution. Just those 4 answers between 0 and 2 pi. Alrighty, now let me erase. This board is not the best board to erase. Alright, maybe I'll give it a little spray down. We'll spray down here. Clean her up nice. And then we have one more problem to do in this video. Okay, our next problem is secant squared of x equals tan x plus 3. All right, so if you look at this, we have two different trig functions in the problem. It would be great if we could get it down to having only one trig function, right? So you want to look at your formula sheet, or use your brains if you have your formulas memorized that you're supposed to have memorized, and think, what formula links secant and tangent together? All right. You got it? The correct answer is the Pythagorean identity for secant and tangent. It tells us, actually, that Pythagorean identity says that secant squared is equal to 1 plus tangent squared. Okay, so we're going to make that substitution here. This becomes 1 plus tangent squared. And then now we have everything in terms of tangent. We're going to get everything on one side of the equation. So I have tangent squared. I'm going to subtract this tangent over there. We have a 1 here. I want to subtract the 3 from it, so we get minus 2. All right, so that equals 0. Now, we're going to make a substitution. So we're going to let u equal tan x, because that just makes our problem look simpler for the time being. That gives us u squared minus u minus 2 equals 0. And that's a quadratic equation, right? We all know how to solve quadratic equations, I hope. You can use your quadratic formula if you want, or you can factor it if it factors. This one does factor, so I'm going to go ahead and do it that way. All right, it factors into u minus 2, u plus 1, and we're going to set these equal to 0 separately. We get u equals 2, and we get u equals negative 1. U was just a placeholder, though, for us. U was holding the place of tangent. So what we really have here is that tangent equals 2, or tangent equals negative 1. So now, if you look at these, think to yourself, can you use the unit circle for either one of these? We can use the unit circle here for tangent equals negative 1. That happens at, what, 3 pi over 4 and 7 pi over 4. But since it's tangent, oops, I forgot my x, we can just say that it's going to be 3 pi over 4, just take one of our answers, and add on pi k, right? Because that would give us the next answer and then all of the rest of the potential answers. What about this one, though? Tangent equals 2. That doesn't happen on the unit circle, so we would need to use inverse trig to solve it, right? We need the arctan. Our answers would be, since tangent's positive, in the first quadrant or in the third quadrant, right? We would have the same reference angle there. So we just need the first quadrant answer and then add pi k onto it. And that's easy, right? The first quadrant answer is just the reference angle, which is arctan of 2, and we're going to add pi k onto it. All right, so these are our answers, and our answers between 0 and 2 pi are going to be arctan of 2. That's what you get if you put 0 in for k. Arctan of 2 plus pi, that actually gives us that third quadrant answer that I drew there. 3 pi over 4 and 7 pi over 4, right? We talked about earlier. That's what you get when you add pi onto 3 pi over 4, if you plug 1 in for k there, right? And that's going to be it, all right? So those are the 4 solutions there. All right, that's the end of this video. See you later.